Welcome to channel Madam Won. Today we are going to learn how to interpret speed-time graphs. How do you interpret speed-time graph? Line PQ here. The speed of object increases from u meter per second to v meter per second. The gradient of graph is positive, hence the rate of change of speed is positive. Line QR. There is no change of speed, zero gradient. The object moves at uniform speed. Line RS. The speed of object decreases. The rate of change of speed is negative. The motion of the object remains in the same direction. So this part we call it as deceleration. Question 1. The speed-time graph in diagram 1 shows the movement of a particle for a period of time. A. Describe the motion of the particle when it moves at a uniform speed. How to describe? The particle moves at 14 meters per second in 7 seconds. Or the particle travels for 98 meters at a uniform speed. From the graph, this part is uniform speed. The speed is 14 meters per second from second to 9 seconds. So the duration for uniform speed is 7 seconds. That's why we can write as the particle moves at 14 meters per second in 7 seconds. Or we can find the distance. Distance is area under the graph. So 7 times 14 equals to 98 meters. So we can write as the particle travels for 98 meters at a uniform speed. B. Calculate the rate of change of speed in meter per second square for the first 2 seconds. The first 2 seconds is here. The formula for rate of change of speed is equals change of speed over change in time. Okay, so for first 2 seconds, change of speed is 14 minus 3. Over the time 2 minus 0 equals 5.5 meters per second square. C. Calculate the total distance in meters traveled by the particle in the period of 9 seconds. So as we know, the total distance equals area under the graph. So in 9 seconds, area under the graph, we can divide into 2 parts, part A and part B. Total distance equals area A plus area B. Area A is a trapezium. So we use the area of trapezium to find the area A. So what is the formula of area of trapezium? 1/2 times A plus B times the height. So parallel lines here is A and B. And distance between 2 parallel lines is h. So the area of A equals 1/2 times 3 plus 14 times 2 minus 0. Whereas area B is, here is 9 minus 2 times 14. Area A equals 17 and area B equals 98. So the total distance is equal 115 meters. Question number 2. The diagram 2 shows the speed-time graph of the movement of a particle for a period of 20 seconds. Describe the motion of the particle for the first 5 seconds. So for the first 5 seconds is here. How to describe? First, we find the rate of change of speed. Change of speed equals change of speed over change in time. Or we can use the formula final speed minus initial speed divided by change in time. Change of speed equals at minus 0. Change in time is 5 minus 0. So rate of change of speed equals 1.60 meter per second square. So how to describe? The particle accelerates at a rate of 1.60 meter per second square for the first 5 seconds. B. Calculate the rate of change of speed in meter per second for the last 5 seconds. So for the last 5 seconds is here. 20 minus 15 equals 5 seconds. Rate of change of speed equals final speed 0 minus initial speed at divided by 20 minus 15 equals negative 8 over 5 meter per second square. So for this part, negative you cannot change to positive. Negative means that the deceleration. C. Calculate the distance in meters traveled during deceleration and describe the motion of the car for the period. Okay, so deceleration, you know, is here. Okay, total distance of deceleration is area under the graph here. Total distance equals 1 over 2 times 20 minus 15 times 8 equals 1 over 2 times 5 times 8. Total distance equals 20 meters. So now we describe the motion of the car for the period. So the particle moves for 20 meters in 5 seconds with a deceleration of 8 over 5 meters per second square. So now when we write the word deceleration, we cannot put negative here already because this. If you like my video, please feel free to like and subscribe to my YouTube channel. Thank you.